Okay, so we have the problem. A cannon shoots a clown that has a mass of 70 kilos. If the cannon has a mass of 500 kilograms and the clown's velocity out of the cannon is 42 meters per second, what must the velocity of the cannon be? So first we have a mass of 70 kilograms, and that is the clown. Then we have, if the cannon has a mass of 500 kilograms, we have the mass of the cannon. And the velocity of the clown is 42 meters per second. What must be the velocity of the cannon? So this is our unknown, the velocity of the cannon. So this would be after it was shot. So I'm going to box our question and then underline our givens. So to do these problems, first thing I'm going to do is draw a picture. So first thing we have a cannon. Let's go real bad. Cannon, and it is shooting a clown. So the cannon has a mass of 500 kilograms. Clown has a mass of 70 kilograms. And then also it says velocity initial. So when the clown is actually shot, the velocity is going to be 42 meters per second. Okay. With this, what I'm going to do is I'm going to draw a like a picture diagram, and this is going to help us know what equation we are going to use to solve this problem. Notice our equations are in black over here to the right, and that'll help us out. So first thing I'm going to do, draw a little T-chart. So we're going to have initial on the left side and final on the right side. So initial, this is what happens before the cannon is shot. So before it's shot, how fast should the cannon be going? The cannon shouldn't be moving if it hasn't been shot yet. So we have a cannon. Notice the clown also would have a velocity initial of 0 because if it hasn't been shot, he is still inside of the cannon. And so what we can do is we can actually add their masses. So we would have the mass of the cannon plus the mass of the clown. So we're going to have 500 kilograms, so the mass of the cannon, plus the mass of the clown. So we're going to have mass is 570 kilograms. The velocity at the beginning is going to be 0 meters per second. We have nothing else on the initial side. Then what we're going to do, once we hit this line, we need to make an equal sign. So we're going to make an equal sign here. Ooh, that's a nice pen. Then we're going to have final. Okay. Now this is when the objects separate. So now we have a cannon, and then we are going to have the clown. And in between pictures, what you need to do is put a plus sign. So in between these, let's give him curly hair because he's a clown. So we have the cannon and we have the clown. In between, make sure you put a plus sign. So the mass of the cannon, we know from the givens, it was 500 kilograms. Velocity that the cannon is moving after it was shot. If you look up above, remember that was our unknown velocity of the cannon. That's what we circled, so we don't know this value, so I'm just going to put a question mark. Then I'm going to go to the clown. We know the mass of the clown, 70 kilograms. Then we also know the velocity of the clown. This is after his shot, so it would be final. It's 42 meters per second. So based off this is technically our givens and our unknown. Notice our givens, mass and velocity initial, mass, final velocity. Our unknown would be the final velocity. Notice I color-coded it because I think it makes it a lot easier. So based off this diagram, you should be able to pick which equation we are going to use. If you notice, on the left-hand side, we only have a mass and one velocity because they have the exact same velocity. So if you look at the first one, we would not use it. Look at the second one, would not use it. Third one, the reason why we picked this one is notice they have the exact same velocity. Since they have the exact same velocity and then they have two different velocities on the final, that is the option we're going to pick. So this is going to be our equation. Notice you can actually get this straight from the picture as well. It's just beneficial for some people to see it more than one way. So the equation is going to be, and again, I'm going to color code it because I think it makes it a lot easier. So velocity initial, we had is 0 meters, VI, and then we're going to have M1, so this would be, I guess we already added them, so we'd have the mass. It would be 500 kilograms would be the cannon, and then 70 kilograms would be the clown, or you could just put 570. It's literally the same thing, but that would just be mass cannon, mass clown. Now we go to the equal sign. Now we're going to do mass of this object, velocity of this object. So we have mass, the cannon, velocity. Okay, notice this is going to be our unknown. So this is going to be our unknown. So I just put an underline under it just so we know it's the unknown. Then we're going to have mass and velocity final of the clown. Notice we're going to actually have those values. So what I'm going to do now is I'm going to rearrange. And so I'm going to solve for velocity. So remember to do PEMDAS backwards. So we're going to subtract first, then we will divide. So I'm going to subtract first. So we're going to have VI. I'm going to add these two together. So we're going to get 570 kilograms. And we're going to subtract this mass and velocity. So I'm subtracting MVF. And then what I'm going to do to get this velocity by itself is I'm going to divide by this mass. Notice it needs to be in red. So I'm going to divide by this red mass. And it is going to equal our VF. Okay. To plug in, I'm just going to do it right up here. So to plug in VI, notice we need to go to green. So VI would be 0 meters per second. Masses, I don't know why, but I already plugged those in. And then we're going to subtract orange. So now we're going to go to this object. We're going to have 70 kilos times 42 meters per second. Now we're going to divide by the red mass, so we need to go to this object since it's in red. Divide by 500. We will get a value of negative 5.88 meters per second. The reason why it's negative is because if the clown's going forward, the gun needs to go backwards. If you've ever shot a gun, it goes backwards while the bullet goes forward. Also notice the reason why we got meters per second here, kilogram is in every term, so we can cancel out our units, and we're left with meters per second minus meters per second, which when you add or subtract units, your units don't change. So if you cancel these out, we're left with just meters per second.